All right. I apologize. I noticed when I was watching back through the video yesterday, a couple may have not been that clear. There was some glare on the board. So I'm back to the paper here for these. But if you didn't see them, you kind of got close, that's fine. But I'm going to go through these and then we're going to look at one new thing today. But basically, okay, so I put some on the, where I switched the order. I put some where the variable's on the right side. I use negative numbers and kind of mix that up a little bit. So, but the same process, you're trying to get this over here. So you just cancel those out and you're left with a positive x. See, that's a positive x equals 32. Okay, and then over here, I want to move 10, but it's a negative 10. So to get it to 0, I'm going to add 10. And once again, a positive y equals 23. Okay, same thing, add 4, add 4. The difference is this is already a negative number. You add 4, you're at negative 6. Okay, then you get to this one. To move the 3, you got to subtract. But the difference is on this one, you've still got a negative y. Okay, so you moved your 3, but you got a negative y, which means you need to change the signs on both sides. And y is negative 12. Same thing, add 12, and you've got a negative y equals 16. So you move the signs, and it's negative 16. Okay, add 3, and this one's going to be, okay, so it's a negative m, it's still a negative 5. You change the sign over here, so you change the sign over here to a positive 5. Okay, now we've got them on the right side, and remember I told you the first thing you can do is just switch places. Okay, put this side over here, put this side over here, and now all you have to do is add 10, and x is 22. And you really don't, later in math, you don't actually even have to do where you put it on the left side. But, for right now, it's good to learn that because it's always reading out then x equals this or y equals this. So same thing over here. Let's change places. Put this side over here, put this side over here. We're not changing any signs. We're just making a mirror here. And now we can move the 18. You get negative y is negative 22, which when you change the signs to both, you get positive 22. Okay. Same thing, change sides. Okay. Then you can move the 15. And you get 22, and then you just need to get rid of the negative. And it's on this side, so it's negative 22. Okay, this, you can move the 8. Okay, and then change the sign, so you change the sign. Last one, we change sides first. Then you move the 8. And then you change the signs to make it a positive x. Change it to a positive 32. So I went kind of quick on those, but that's so you can go back through. You can slow them down and check your answers and see maybe where if you missed one. Just remember the kind of the main things is, you're isolating the variable. You're, maybe on a 1 that you've got a negative, you're just changing the signs at the end. And then the other thing is if it's on the right side, just switch places first and then go from there. Okay. Now, the next thing I want to cover on these one step. Now, there's going to be, we're going to wrap up one step kind of around here and work through some of these new problems. And then I'm going to kind of change gears as far as equations and do what we call combining like terms so that we can move into maybe two-step equations a little bit bigger. Like I said, we're staying with equations, but there'll be a little bit of knowledge of things that we'll cover so that we can move into some longer problems. These are still considered one-step equations here, but so far, if you've noticed, all we've done so far is when we have a single x or a single y, right? Now, it could be negative or positive, but they're just single, right? It's just one x, one y, or one m, and then we're either adding or subtracting from that x or y or m or whatever letter we use. But there's only one of them, okay? Well, what happens when you've got like 3m equals 12, okay? Now, we're not taking anything away from m or adding to m. We just have 3 of them, okay? And that's one example of a different thing. Another thing is, what if we are dividing a letter by something? So x divided by 5 is 4 or something, okay? So once again, we're not subtracting or adding anything from x, but we're dividing something from it. And in here, even though there's 3 of them, we're actually multiplying. Remember, when you got 2 things written by each other, you're multiplying them. Okay, so this is not addition or subtraction, it's multiplication and division. Now, they're still considered one step because we're going to learn the process to solve this in one step. So it still fits in that one step, just like these were one step, even though you could argue that these were actually 2 right here when you had to change the negative. But, you know, we subtracted 8, we solved it in one step, okay? These are also one step, but we're not subtracting or adding, we're multiplying and dividing. Now, the hardest thing to kind of grasp at first with this is you're going to see, well, what's the difference between this and this, okay? So here's what we've been doing, and we are now moving into this, and I want to show you the difference of this. Now, the answer to this one is going to be 9, right? 9 plus 3 is going to give me 12. And how we found that was we isolated the variable, we subtracted 3, we got rid of this constant, and we moved it over here. Okay, this is not a constant, this is a coefficient because it's written before. It is a constant number, it's a single number, but if you think about it, we don't want this to become 0. Like this, we want it to become 0, we want it to disappear, become nothing, because when it became 0, this was isolated. Well, if this becomes 0, 0 times anything is 0, and that gets rid of everything, gets rid of the letter and everything. We don't want that. We want that variable still left there. That's what we're doing when we're isolating the variable. We don't get rid of the variable, we isolate it. So we don't want this to become 0, this 3, okay? In this case, we wanted it to become 0 right here, because then it disappeared and it left us with just our letter. See, we subtracted 3, that got rid of it, and we're left with our letter. If we make this a 0, then it's going to be 0m, which 0 times m is 0. And there's nothing there. There's no more variable left. So we can't just subtract 3 from here. And you'll also see that that wouldn't give us a correct answer. If I subtracted 3 and somehow got that, you know, rid of this, and you got m, and you subtract 3 is 9, is 3 times 9, if we plug it back in, 3 times 9 is not 12. Okay? This one, if we subtract 3, and we get m is 9, we can plug that back in. 9 plus 3 is 12. So we can't just solve this by subtracting 3, but I want you to look at the difference. This one is, we're subtracting 3 because we're getting rid of just this. Okay, and we're left with m. Right here, we want this not to be a 0, but we want it to be a 1, right? Because when we're done, we want it to look something like this. A single m equals whatever we're going to get over here. Well, a single m, we know, remember that, there's a divisible 1. So we need this 3 to become a 1. Now, that doesn't mean we're going to subtract 2, okay? Because then that would change every time. We would subtract 2, but if it was a 9m, we'd subtract 8. That's not what we're doing, and that's not the opposite of what we're doing anyway. So what we're going to do is we need this, instead of multiplying by something, okay, let's say I did 8 times 2, okay, is 16, right? And so I multiplied these two things and got 16, 8 times 2 or whatever, and I plugged in 2. Well, if I wanted to get this back down to 2 over here, I would divide by 8. Divide by 8, and you would get 2 is 2. Okay, so whatever you're multiplying by, if you divide it on both sides, you're going to come out to that true statement. Okay, you're going to end up, instead of multiplying by something by 8, if you divide this by 8, you're going to get back to your original number. Well, we want to get back to this original n. So I always, and that starts to be confusing if you're really trying to figure out. The best way to kind of remember it is you're doing the opposite. So instead of adding 3, you subtracted 3. On these, if I m minus, well, let's use a different letter. X minus 2 is 14. Instead of subtracting 2, we added 2. So instead of adding 3, we subtract 3. Instead of subtract 2, we added 2. This one, instead of multiplying by 3, the opposite of multiplying is to divide. And I'm going to do it like a fraction because, for one, it'd be hard to write the little division sign by 3. This is the most efficient, quick way in one step that we can do this. So instead of multiplying by 3, we're going to divide by 3. Okay? But remember, whatever you do on this fence, you do over here. You're going to divide this by 3. And so these cancel out. They become 1. 3 divided by 3 is 1. 1m equals 4. 12 divided by 3 is 4. Now plug that back into your original problem. Okay, and plug a 4 in, and we get a true statement. 12 equals 12. Okay, let's do another one. We'll come back to the division one here, but let's do another one. 4x equals 20. Okay, so instead of multiplying by 4, I'm going to divide by 4. Do it on both sides of the fence, and you get 5. 20 divided by 4 is 5. If you plug that back into the original problem, 4 times 5 is 20. Okay, so you're just doing the opposite. Instead of multiplying, you're going to divide. Okay, now here's this problem. This one is a division problem. So what's the opposite of division? Multiply. So instead of dividing this by 5, we're going to multiply this whole thing by 5. What you do over there, you do over here. Now I'm using parentheses so that you don't think this is 45 and that I know to multiply this. Okay? Now, we could go through a whole fraction lesson again, which I'm sure most of us don't want to do. But it's kind of like this same thing. If you multiply by something but then divide it by the same thing, or if you divide by something but you multiply by the same thing, they cancel out. They become 1. This becomes x over 1, which is just x. Okay? That's, to me, the short and quick version to know if you multiply, if you divide by something but then you turn around and multiply it by the same thing, you're going to get that top answer. It'd be like this. 8 divided by 2 is 4, but if you take that and multiply that by 2, you're still going to get 8 up here. So think about it. Like, if 8 divided by 2 is 4, but then you take that and multiply it by 2 again, you're going to get back to your original start. So 8 divided by 2, but then multiplied by the same number, you're going to end up back where you started. Okay? And I said, like I said, that could be confusing. I'm just trying to explain to you that this works. Okay? Instead of dividing by 5, but you turn around and multiply by 5, you're going to end back up with what you started, which is what we're trying to do. Okay? So instead of dividing, but if you go back to that easy rule of the opposite, instead of dividing by 5, you multiply by 5, well, then you're going to end up back where you start. And then 4 times 5 is 20. Okay? Plug that back into the original problem. 20 divided by 5 is 4. Okay, so let's do another one of those real quick. Y divided by, let's do 3 equals 9. Okay, now this almost looks like, well, this is going to be 3. Well, no, 3 divided by, if I plug in 3, 3 divided by 3 is 1, not 9. So we're doing the opposite of division, which is multiplication. We're going to multiply both sides by 3. These cancel out, and you're left with 27. 9 times 3 is 27. Plug that back into your original problem. 27 divided by 3 is 9. Okay? So it's not hard once you get that, just that first step. Once you get what to do on that first step, the math of it is really not that hard. It's just getting used to what to do, you know, to solve those. So let me put you some practice problems, and you can go back through and kind of watch that. Main thing to remember is that you just do the opposite. So, you know, 3x equals 15. Okay, so instead of multiplying by 3, you're going to divide both sides by 3. So I kind of told you how to do the first one. I got to make, and I'm trying to make sure these come out evenly, okay, to where you're not, you're getting a correct answer, something like not 23 divided by 4 or something that doesn't come out. They can, you know, math gets hard enough where it's not going to always come out even, but I'm trying to keep these even. So 2y equals, let's go big, 48. Let's do some division. So y divided by 5 is 10. X divided by 4 is, now these don't have to come out even because you're just multiplying both sides. And then let's do X. Okay, so do those 6 problems. You know, do the opposite of what's showing. Then we're gonna, like I said, we're gonna kind of switch gears a little bit, staying on equations, but we need to learn something first before we can move on to bigger equations, okay? All right, thanks guys.